And we are live. Good morning. How are we all doing? Let's get some sun in here. It's cloudy, but that's okay. How are we all doing on this fine Thursday? Well, let me chat on this. Not in the mood to chat today. That's okay though. So, this is the last lesson in rationals. There we go. Good morning, Hannah. Good morning. I'm doing okay. A little, really busy. Really busy. This online stuff is a lot of work. May not seem like it, but man, I am really busy. Phone calls, meetings, extra formatting and lessons and things like that. It's a lot. It's a lot that's going on. But I'm keeping my cool. Cabin fever hasn't gotten too bad. Been able to socialize a little bit online with friends and stuff, which is good. I'm just pushing on, pushing forward. I'm glad that you're doing all right, though. Anything new, Hannah? Nope, just staying at home. Nice. You playing any new games? You playing that new Animal Crossing game? I don't know if, like, how badly the delay is. It says it's only a few seconds. So much Animal Crossing. Yeah, everyone I know is playing it, but that's cool. I have a Switch. I don't know if I'm going to get it. Final Fantasy VII comes out tomorrow. I think I'm going to get that and play that. It's going to be awesome. But let's get into rationals, especially rationals in which we're solving inequalities. When we're rational and we're solving inequality, we're looking for two things. We're looking for the zeros, and we're looking for the undefined values. We call those critical values. Those are the vertical asymptotes or the points of discontinuity or holes. So we need to look at those. So for example, I have this x minus 3 over x plus 2. I basically, and we know that I'm going to say equals to 0 because it's an inequality. So we pretend it's an equal sign. So my undefined values, x cannot equal negative 2. And then on top for my zeros, if I have x minus 3 equals 0, and I get x equals 3. So these are the important values. So now we test that on a number line. All critical values, those are the values that are going to be undefined, are always going to be open circle. So the negative 2, this is going to be an open circle. And then the zeros are open or closed circle dependent on the problem. So in the problem itself, because it says less than or equal to, that means that my 0 is going to be closed circle. So now we can solve this two ways. We can either do the sign chart, or you can just plug them into the original and see if it's true or false. So for example, if it says x minus 3 over x plus 2, that's less than or equal to 0. Values that are less than or equal to 0 are negative values. So I'd be looking for negative numbers. So if I plug in a value over here like -3 and I plug that on top, I get -6 over, and then if I plug -3 on the bottom, I get -1. Well, negative over negative is a positive. Then if I plug in a value like 0, so I get 0 minus 3, which is -3, over, if I plug in 0, I get 2. A negative over a positive is going to be negative. And then if I plug in a value over here like 4, if I plug in 4, I get 4 minus 3, which is 1, over, if I plug in 4, 4 plus 2 is 6. That's positive. So we said the values that we were looking for are the negative values. So my answer is going to be from -2 to +3. And that right there is going to be my answer. Any comments or questions on that? Bum, ba, bum, ba, 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 bum. Okay, let's look at another one. Number 2, 4x over x squared plus 4 is greater than or equal to 0. So my critical values, the values that could be undefined, if I set the x squared plus 4 equal to 0 and solve, -4 square root, I get x equals plus or minus 2i. Well, since the values are imaginary, that tells me that there are no critical values. There are no solution that's going to get, no real solution that's going to give me 0. So then I just worry about the top. I set the top equal to 0. Solve. I get x equals 0. So on my number line, the only value I have is 0. Values that are greater than 0 equal positive numbers. Whoops. Positive numbers. So a value, since it's equal to, my zeros are a closed circle. So testing a value on this side, like -1. 4 times -1 is -4. -1 squared is going to be 1. 1 plus 4 is 5. So that's going to be negative. Plugging in +1. 4 times x, so 4 times 1 is 4. 1 squared is 1. 1 plus 4 is 5. So that's going to be positive. The values that are positive are my solution. And so that's going to be from 0 to infinity. Now, I know that I'm practicing using the sign charts. You don't have to use the sign charts. You could just plug the values in and see is it true or false. I think the sign charts are a little quicker. Practicing the sign charts now are going to make certain things in calculus a little easier because you do a layered sign chart. You're going to do a generic sign chart like we're doing now on top of a derivative sign chart on top of a second derivative sign chart. So and then you compare them and that gives us information. So for this, practicing the sign charts is going to be very helpful, but just know that technically you can just plug it in and see if it's true or false. If I plugged in -1, I get -4 over 5. Is that greater than or equal to 0? That's false. That's false. That's why I didn't shade it. So it's the same thing. Now I'm going to skip to number 4 because number 1 is basically the same thing. Not number 1, but number 3. Just let me point out one thing. For number 3, we will have some factoring to do. So factoring the top, you're going to get x plus 3 times x plus 2. And then on the bottom, you're going to get x plus 1 and x minus 1. So my critical values would be x can't be -1 and +1. And then my zeros set the top equal to 0. you're going to get x equals -3 and -2. And so those are the values that you put on a number line. They're all going to be open circle because there's no equal to. And then you test and you see that. All right, so number 4 is kind of important. And the reason why number 4 is a little important is because if you notice on number 1, 2, and 3, the biggest thing in common is the fact that they're all compared to 0. It's one thing and it's compared to 0. One thing compared to 0. One thing compared to 0. We want them all like that. We all want them in the format of one thing compared to 0. We want one thing compared to 0. So we actually have to spend the time making it look like that first. And so the way we do that is it's going to be bringing everything to one side and then finding the common denominator. So let's look at this one. So we have x to the 4th minus 4x to the 3rd plus x squared minus 2x minus 15 over x cubed minus 4x squared is greater than or equal to x. So I'm going to minus x on both sides. So I'm going to get x to the 4th minus 4x to the 3rd plus x squared minus 2x minus 15. So that first thing, it being compared to 0, check. It is now being compared to 0. But I don't like this. This makes things very confusing for us, right? It makes it much more difficult for us to be able to find the zeros and find the undefined values. So I need to find the common denominator and then combine them together. So that's my denominator here. I don't have that same denominator there. So I'm going to multiply top and bottom on this side by x cubed minus 4x squared over x cubed minus 4x squared. So that's going to give me x to the 4th minus 4x to the 3rd plus x squared minus 2x minus 15 over x to the 3rd minus 4x squared minus x times x to the 3rd minus 4x squared over x to the 3rd minus 4x squared. So now I just need to distribute this. So if I do, that's going to give me x to the 4th and then minus 4x to the 3rd. Now, if I wanted to distribute the negative, let's just distribute the negative. So then that becomes negative and then that becomes positive. Because now I can combine these together into one thing. I have an x to the 4th here. And an x minus x to the 4th, so those cancel out. And then I have a negative x to the 3rd, 4x to the 3rd, and a positive 4x to the 3rd. Those are going to cancel out. Well, then the rest is going to be x squared minus 2x minus 15 over x to the 3rd minus 4x squared. And that's going to be greater than or equal to 0. From there, you're going to factor the top, factor the bottom to find your critical values and your zeros, put them on the number line and test. Comments or questions about that one? So basically, we combined it into one rational expression. So those two criterion, we want it equal to 0. We want it one rational expression. And the reason is that just makes everything else easier. Technically, you don't have to do any of that, but then to get rid of the bottom, to set it equal to 0, to do this, to do that, like it becomes increasingly complicated. So by it equaling 0 and it being one expression, instantly these become your critical values. these become your zeros to put on the number line to be able to solve. All right, let's move on. So it says state the vertex, axis of symmetry, domain, and range, axis, blah, blah, blah. All right, so we need to find all this stuff. So for number 6, I'll do that one. That's f of x equals 2x squared minus 4x plus 6. So it'd be easier if we put this into graphing form. So if I factor out that 2, and we isolate the 6, now I can complete the square, b over 2 squared. So that means we're going to add 1 and subtract 1. That factors. And then now we distribute the 2. So then I'm going to get 2x minus 1 squared plus 4. So now I have that. I can start finding all my values. So 1, 4. And, you know, however accurate I'm able to draw that. But you can create a table and do that. I ran out of room. I put it too high. So, but my horizontal shift is 1 and it's going to go up 4. So finding the pieces of information, it asks things like the vertex. So that's 1, 4. It asks for the domain. That's negative infinity to positive infinity. The range, it starts at 4 and then goes up. So 4 to infinity. Intervals of increasing and decreasing. So as I'm moving this way, my graph is moving down. So it's going to be decreasing from negative infinity all the way to the x value of my vertex. And then as I'm moving this way, it's moving up. So that's going to be from 1 to positive infinity. Let's see, what else is it asking? Axis of symmetry. So the axis of symmetry, that is the vertex value because that's where it makes everything symmetric. And then x and y intercepts. There are no x-intercepts here. If I look at the original, my y-intercept, if I plug in 0 for x, so it's just going to be y equals 6, so the point 0, 6. The extrema for the max and min, the lowest value on my graph is 4, so it has a minimum of 4. There is no maximum. I think that's all the values. I didn't pause it. I'm so sorry if I blew you guys' brains out. I tried to pause it or mute the mic. All right, number 7. Three 70 degrees and x. So find the measure of each side. It's a right triangle. So right triangles mean that SOHCAHTOA works. So I need to know the relationship between this. I have the opposite and the adjacent. So opposite and adjacent means that it's going to be tangent. So this is going to be the tangent of 70 degrees equals opposite over adjacent. Get x by itself, multiply both sides by x. divide by tangent 70. And then this right here is going to be our solution. Enter that in your calculator. Comments or questions on that? All right, so number 9, to solve the polynomial inequality. So 4x to the third, and I'm going to bring everything to one side. So minus 3x minus 1 is greater than or equal to 0. Got to do my p's over q's. So plus or minus 1 over the factors of 4. So I'm going to get plus or minus 1, plus or minus 1/2, and plus or minus 1/4. So plugging those values in, let's try positive 1. So 1, there's no x squared. Bring it down. Whoops, that should be 4. So bring it down, multiply, add, multiply, add, multiply, add. So positive 1 worked. So that gives me x minus 1. And then I have 4x squared, because it's a remainder, constant x squared, plus 4x plus 1. So this will factor into 2x plus 1 squared. If you guys do your Xbox method, 4x squared, 4x. I'm not very good at the Xbox. I do other ways, but essentially by factoring it, that'll turn into 2x plus 1 squared. So then on my number line, I can put my values negative 1/2 and positive 1. And then both of these are going to be closed circle. Now I just need to test. And we can take these values and just do positive or negative and compare it to these. So for example, if I picked negative 2, that gives me negative 3 times negative 2. It doesn't matter because it's squared, so it's going to be positive. So negative and a positive is a negative. 0. So 0 minus 1 is a negative. And then if I plug in 0, it doesn't matter. It's always going to come a positive. So negative positive is a negative. And then plugging in a value like 2. 2 minus 1 is a positive. It doesn't matter if I plug it in, it's going to be positive. So positive times a positive is a positive. And so my polynomial is looking for positive numbers. So therefore, that's what's shaded. So my answer is going to be from 1 to infinity. Comments or questions on that? So for number 12, I have my q of r is 1 minus 16 r to the 4th. It's asking us to find all those different values from it. Well, I'm just going to reorder this because writing it in descending order is always making things easier. So find the degree is 4. So my n is 4. The leading term is that. So the leading term is going to be negative 16r to the 4th. The leading coefficient, that's negative 16. So that's going to be that number. The constant term, that's going to be 1. And the end behavior, so negative and even. So my end behavior is going to model something like that. So that means that as x goes to negative infinity, so as x goes to negative infinity, my y is going to go down forever. So my y goes to negative infinity. And then as x goes to positive infinity, my y goes to negative infinity. And that's my end behavior. Comments or questions on that? Cool. Are there any other questions and anything in this lesson? I know we only have 3 viewers. Starting to get lazy. I appreciate you, Hannah. What a great student. I don't know who else is watching, but whoever is watching, good students. The best. Students that are going to go into AP Calculus next year and succeed and do very well. The rest of you guys, oh no. Okay, well, if there's no other questions, hi Annie. I will see you guys later. Let me know if you have any questions on Discord. More than happy to answer it. I should get next week's schedule updated, and what I'll do is I'll have like a calendar section, and I'll mark it on that calendar. So I think that'll work. So see you, Kira. Have a good one. See you, Hannah. See you, Annie. Good students. Good students.